So before understanding what is molecular dynamics, it's very important to understand what is computer simulation. So I will try to explain it in a very simple manner so that everybody could understand it. So computer simulation is nothing but performing real life experiments in virtual environment. So what we do, we create a virtual world. And why do we create this virtual world? So that we can understand our real environment in a much better way. Now coming to molecular dynamics is also a type of computer simulation. Okay, so another name that is given to molecular dynamics is atomistic simulation. So what we do, we study the theory of material at atomic scale. Okay, and after studying their theory, we model that material. So in atomic simulation or in molecular dynamics, initially what we do, we need to understand the motion of each atom. Okay, like when you want to do the simulation for a particular material, you want to create the atoms. So after creating atoms, how those atoms gonna interact with their neighbor atoms. Okay, so and how they are going to move during the time period of your simulation. So first you need to understand their motion, how they're going to interact during the period of simulation. And once you understand the motion of atoms, after that you need to create their model so that you can perform your simulation work. We can understand it through a example. Okay, so here is a example of liquid water. Okay, suppose you have a liquid water and you want to simulate it for uh, certain kind of property. Okay, you want to calculate, let us say you want to calculate its property at a certain higher temperature that is impossible to do in real life. Okay, so what we will do in molecular dynamics, or what we can do in molecular dynamics, is we can calculate its instantaneous position and velocity of each atom in the liquid. Okay, that is the beauty of molecular dynamics. We can calculate the whatever property. It's not about the position and velocity, but whatever property we want to calculate for our material. Okay, we can we can find it for a very individual particle. But what we do in real life experiments, it's impossible to find a property of a single atom or a single molecule. So what we do in real life experiments, we calculate the average property of large number of particles that is averaged over a certain period of time. So we calculate the bulk behavior of the material. Now, to calculate the bulk behavior of material uh, using molecular dynamics or using computer simulation, it's very important to understand the concepts of statistical and classical mechanics. Uh, because statistical mechanics and classical mechanics are the basic foundations of molecular dynamics, and we will discuss this in our next lecture. Thank you.